Hello everyone, today I'll be giving you a demo of how to use Modelsim and Quartus. So the files you will need are all available on Piazza. They are pbtop, pbtop.tb, and pbpins.csv. They're all on Piazza. If you don't want to download the ones on Piazza, you can also follow the handout, which is on Piazza, and type them out yourself. But in the interest of time, we will just use the ones on Piazza. I've also made a copy of these in another folder called Synthesis, because that keeps things organized. So let's get started on simulation. I'll open Modelsim first. So we have Modelsim open. You should get something similar to this. We'll make a new project. File, new project. And we can call this pbpins sim, or anything you want. Don't add weird things like spaces in the directory. Don't make the directory too long. Keep it simple. Or else you will have a very painful time debugging why Modelsim doesn't want to work later. Simulation. So we have selected the directory. The directory placed our Verilog files in, and we'll click OK. You don't have to change any of the other stuff. Okay, we have created it. So you will get something similar to this. So we can add the existing files we have. We'll add pbtop, pbtop.tb. Just a reminder, this should be in your simulation folder. So click OK, OK, and we can close. We'll now compile it. Right-click, compile all, and it should compile fine. After all, this is Professor Tor's code. He would not give you bad code. Now we can start the simulation. We can do that. Hit the start simulation. It will be under work, and we will select the test bench because that is what we're simulating. And there will be lots of flickering, but that's fine. Okay, now everything is loaded. We'll just drag all the signals in. You would typically be a bit more selective in the signals you drag, but there are only a couple, so I'll drag them all. And then we can, there are two ways. We can either type it in the console, run -all. I know, run it. I'm hitting Control+ to zoom in, and you can see the waves here. We can also see the console outputs. So the output is here. Alternatively, if you didn't want to do run all, I think you can also go here and select run and run all, and that should have the same effect. But typing it is faster if you are repeating this multiple times. And that brings us to the end of the Modelsim section. We will now move on to Quartus. Okay, so I will open Quartus. Okay, Quartus is now loaded. We'll create a new project. Hit next. We will select the synthesis directory you created, which was a copy of the simulation. Select. We can name it whatever we want, but typically you would name it after the top level design entity. In this case it would be PB pins. I'm going to double check. So I will just double check the top level module. Synthesis PB top. Okay. Computer's a bit slow, but desktop synthesis PB top, will open it and check the name of the top level module. See here, we have confirmed the top level module name is PB top. And an important thing to highlight is that we are selecting our actual module, not the test bench, because you can't synthesize a test bench. So PB top. Okay, next. Select empty project. Next. If you want to add some files but not all, we can go into synthesis and select 1, 2 and open. Or we can hit the add all button, that also works. And we'll go next. For this, I have this remembered, but you can also look it up in the tutorial handout. And then it's this one. And we'll hit next. Hit next. And hit finish. We will wait for the project to load. Okay, the project is loaded. We can go to files and see the files here and open them. We can also make some changes to it. Now we will set the assignments for the pins. Let me make the window bigger. So recall the CSV file, pbpins.csv. We will import that. Open. Hit OK. Okay, the import is complete. Now we can synthesize the design. We will hit compile design. This is usually the longest part of the process and it can take a few minutes. I have designs that have gone up to 40 minutes before, so we will have to wait patiently. As you can see, we have some inferred latches. Okay, it has now finished compiling and synthesizing. So we will now walk through the process of uploading it to the DE1 SoC. So to do this, first get your DE1 SoC out of the box. Then plug in the power cable. That is the big black block. Plug it into your DE1 SoC and switch it on with the red button. Then you will connect the white cable. It's really long. It has a USB-B at one end. Plug that in. You can refer to the handout for what I'm talking about. And then we will now upload it to the board. I have just also plugged mine in, so Tools, Programmer. I'll delete everything so it'll look similar to yours. Usually it should pop up, but if it doesn't, click Hardware Setup and select DE1, DE SoC. Usually it'll show up here, and then hit Close. After that, hit Auto Detect. Select this one, the second one, 5CSEMA5. Hit OK. And then this should show up. Now I will add the SOF file. So click on this and hit Add File. It will be in Output Files, and it will be named pd_top.sof. .sof files are the output files. Hit Open. And then make sure Program is selected. Hit and it should work. Okay, let's close that. Hit No. Finally, there are some other bonus items. So we can take a look at the netlist viewer. Netlist viewer here, RTL viewer. And then we can see the layout of the thing, of the design. We can see the gates. Let's see what else. So thanks for watching.